Now, let's look at the second example. A box slides down on the frictionless inclined plane with a 30-degree angle. Okay. Please write down the Newton's second law for the box. Okay, slides down like this. So we are starting this box, and we try to identify all the forces acted on this box. Okay. How many forces do you have acted on this box? Which one? Gravity. Do you have any other force? No. Don't forget the normal force. Okay, it's still supported by the inclined plane. Otherwise, it will drop vertically. Okay. So you have two forces. One is downward gravitational force. Another is the normal force, which is perpendicular to the inclined plane. Please note that it's not upward. Okay. Is perpendicular to the surface. So the normal force, supporting force, may not be upward. We don't have anything else. We don't have frictional force because frictionless. And we didn't give it any external pulling or pushing force. It's sliding down by itself. Okay, so we have only two forces. But again, we need to do the decomposition. So we have to establish some coordinates. Okay. Now, first, let's look at if we do a normal coordinates like this. Okay. Positive x, positive y. So the normal force is along this direction. The weight, W, is along this direction. Okay. The angle here is 30 degrees. That's is that 30? Okay. Now please note that if this is 30 degrees, our coordinates to make a coordinate like this. If this is 30 degrees, then this angle is 30 degrees. Can you see that? Okay. In your class of geometry, you have some theorem to identify, or you can use some angle relationship to find it out. Okay, so here, do you have any problem with that? This is 30 degrees, okay? So I'm not. So if this is 30 degrees, that means this is 30 degrees in our separate graph. So it helps us to do the decomposition. So we have to decompose normal force N to get Nx and Ny. Okay. According to the graph here, Nx, what is Nx? Should it be N multiplied by cosine 30 degrees or N multiplied by sine 30 degrees? Sine. Please note that in this case, x component is N multiplied by sine 30 degrees. Any question here? The reason is that this one should be the same as this one. And this is opposite, so this is also Nx. Opposite to the angle. And Ny is this one. It's adjacent to the angle. So equals to N multiplied by cosine 30 degrees. Okay. So this is one important step. You should be able to correctly identify which one is cosine and which one is sine. Sometimes x component is cosine. Sometimes n component is cosine. Okay, it all depends on the particular problem. Okay.
Do you have to put if it's negative or positive?
So what I would like to do, okay, there is always the issue of positive and negative. Usually what I would like to do is I put the positive and negative directly in the equation. So I don't put positive and negative here. Even though, okay, of course, you notice that this is actually negative quantity. Okay, so that means I'm going to subtract this quantity from the equation. So I put the negative side here. Okay, and of course, in this treatment, you already put the negative side here. Okay, so you have to put the negative side, but you only need to put it once during the process. Either put it in front of the quantity or directly put it in the equation, but don't do it twice. Okay? Any question here? So now, if you like, you can draw a clear graph after decomposition. Okay, then you have ny here, nx here, w here. Okay, after decomposition, you have the three forces. And then, if this is positive x, this is positive y, so you can write down the Newton's second law. Along x direction, you have only one force, nx. And it's along negative direction. Okay, so the net force is negative nx equals to max. And along y direction, you have ny negative w. It's along negative direction. Okay, equals to may. Now we can simplify it. We know nx equals to n multiplied by sine theta. So you get negative n multiplied by sine theta equals to max. Here you have n multiplied by cosine 30 degree minus w equals to may. In this case, do you have any acceleration component equals to 0? Do you have ay equals to 0? No, okay, this is x direction, this is y direction, and the motion is along some arbitrary direction. So acceleration is accelerated to that direction. So it has both x component and y component. Okay. Any question here? In those coordinates, you have non-zero ax and ay. Now, I'm going to introduce another kind of decomposition for the same problem, so it can improve this issue for the acceleration. Okay. So for the same object, we have the two forces. If I'm going to do this kind of coordinates, positive x and positive y, if I make the positive x direction along the actual direction of the motion, along the incline, let's see what happened, what we got for the two equations. Okay. Now, in those coordinates, normal force N is along y direction, right? It's perpendicular to x direction. And the weight is downward, W. So the force we need to decompose is Wx, which is, this is 30 degree, you can identify, okay? W multiplied by sine 30 degree. Wy equals to W multiplied by cosine 30 degree. Okay? So after decomposition, if you draw the clear diagram, this is positive x, this is positive y. So you have n along this direction, wx and wy. Now, if you want to write down the Newton's second law in those coordinates, along x direction, you have only one force, wx, and it's in a positive direction. You see that? I made the positive direction to downward, not this one. So you get wx equals to max. Okay? Along y direction, you have normal force n positive, wy negative. This is y direction. So I get normal force n minus wy equals to may. It's my two equations along this x and y direction. Okay. Any question here? Now, we can simplify this equation. Wx, according to our decomposition, equals to W multiplied by sine, 30 degrees. Okay, and minus Wy equals W multiplied by cosine, 30 degrees. Now, let's look at the acceleration. In those coordinates, is there any zero component? Yes. Which one? In those coordinates, ay has to be zero because now the motion is along x direction. Okay, we intentionally make the x coordinates along the direction of motion. It's to make ay equals to 0. With ay equals to 0, ax equals to a. So this is ma, this is 0. Okay. So you can see in this case, this equation looks simpler than that equation. So that means this coordinate is a better coordinate than that one in terms of the problem solving. Okay. But both of them are correct. So in any problem, you have to be careful what kind of coordinates you want to use. Okay. If you want to use that coordinates to solve the problem, you still can do that. You can still get the right answer, but it will cost you more effort and time. Okay. Any question about this analysis? And then you can see once you got these kind of equations, okay, the rest of the stuff is purely mathematical issue. Okay, you just need to plug in number, calculate the known and unknown quantity. And physics, okay, is these things: make the graph, identify components, write down the Newton's second law along x and y direction. Okay, that's the important part. You need practice. In fact, I would like to suggest you to practice more on this part. Okay. Later, the calculation. Okay. Sometimes it's not that important. I think to this stage, you should be no problem with equation solving like that. Okay. So some message is that you can try to look at more problem. Okay. You have more problem on the textbook. You can try to look at more problem. But you don't have to get the final answer. What you have to do is for those problems, look at the problem, write down the two equations for those problems. Okay, that's a good practice.